So in lesson 8.3, we're going to look at quotients of powers. We just finished looking at products of powers and powers of powers, and what would happen with the exponents when we had similar bases being multiplied or a power being raised to another power. So today's big idea, because of the relationship between multiplication and division, quotients of powers can be themselves written as powers. So basically we can simplify the quotient of a power into something else. And so our quotient of powers property says that x raised to the n divided by x raised to the m. Notice it's the same base. If it's not the same base, this doesn't work. But if it's the same base, what can we do to simplify this? We can hold on to that base, and with our exponents, we're going to, well, think about it. When we multiplied, what did we do? We added. So when we divide, it's going to be the opposite. And so we're going to subtract our exponents. So example number 1 is going to show you why this property works. So write each of the following in expanded form and then simplify. So if I'm going to expand this, numerator and denominator, the numerator is a to the 7th. So that's a times itself 7 times. 1, 2, 3, 4, 5, 6, 7. And on the bottom, a to the 3rd. Now I'm going to line these up just for a visual here. So we know that when we have a fraction and we have similar things on the top and the bottom, they can cancel and they can simplify. And so this a and this one, this a and this one, and this a and this one will cancel each other out. So this simplifies down to a times a times a times a over 1 when everything goes away. It's a 1 on the bottom. And so we don't even need the 1. We can drop that. And a times itself 4 times is a to the 4th power. Now take a look. Originally we had the 7 and the 3, and we divided. And so if we subtract 7 and 3, we get directly to this. So what about here? So here I have m to the 5th, so 5 m's. And on the bottom, 14 of them. I'm going to line these up. So that's 5. And I'm going to need a lot of room here. 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. And so when I have all of these, 5 are going to cancel. 1's going to be left on top. Now, we can't just drop it like a 1 in the denominator. A numerator 1 needs to stay there. So this is going to be 1 over, and how many are going to be left? 1, 2, 3, 4, 5, 6, 7, 8, 9. So m to the 9th. Now, you might say, well, okay, I subtracted, and 14 minus 5 is 9, and so I want the answer to just be m to the 9th. But that's different than 1 over m to the 9th. Those are different numbers. This actually says 1 divided by m to the 9th. And in the future, we'll learn that this actually equals m to the negative 9th. And if you think about it, we subtracted top to bottom. 7 minus 3 was 4. Well, 5 minus 14 is negative 9. And so it is actually negative 9. But we're going to just leave these like this for now. And so how do we get to here from here without writing this all out? So what you want to think about kind of is these 3 a's cancel 3 of these. So what are you left with? 4 up top, so a to the 4th. Well, these 5 m's are going to cancel 5 of these. I'm left with 9, but they're not on the top, they're on the bottom. Okay, and if they're on the bottom, I need to write it like this, 1 over m to the 9th. So for now, we're going to leave it like this. We're going to talk about negative exponents when we actually get to 8.4, but that's not till after a quiz. So example number 2, let's do this without expanding anything. So we got b to the 10th divided by b to the 2nd. We're just subtracting. So it's 10 minus 2. This is b to the 8th. Another way to think about it is these 2 on the bottom canceled 2 on the top. So you're left with 8 on top, and it's over 1, so it just disappears, so it's b to the 8th. Okay, moving on, example number 2. This is really x to the 1st, remember that. So 5 minus 1, that's 4, so it's x to the 4th. Or think about this 1 cancels one of these. So what am I left with? I'm left with 4 on top. So technically this is over 1, but we don't need to write over 1. Anytime we divide something by itself, regardless of what it is, we know it's 1. So this answer should be 1. Well, let's think about that for a second. If I'm going to use my property, 13 minus 13 is 0. So this is actually n to the 0. Well, anything to the 0 power is 1. And anything divided by itself is 1. All right, moving on. What happens when we have coefficients? So now we're going to see it where we've got some whole numbers in front of this. They're not exponents. They're just whole numbers being multiplied. They're coefficients. We're going to treat them kind of like their own little fraction for a second and simplify them like we always would. Don't subtract 30 minus 5. 30 divided by 5 is something. Okay, so if it cannot be divided evenly, you're just going to simplify it like it's a fraction. But 30 over 5, we can divide that and get 6. And it's kind of like 6 over 1 if we're dividing by 5 on the top and the bottom. So when we go to our final answer over here, I'm going to leave the 6 up top. Now you might say, well, how do you know you're going to have a bottom? But if you take a look, I've got 3 A's on top and 2 on the bottom. So these 2 are going to cancel 2 of these. So they're gone on the bottom. I have 6 B's on top and 1 B on the bottom. This 1 B is going to cancel 1 of them. So that's going to go away. So really this 5 and the A squared and the B are all going to get canceled down to a 1. So there's just a 1 on the bottom. So it's not necessary. You don't have to have that 1 there in this case. But I want you to get used to leaving things as a fraction, because many times, as you'll see on the next one, things are going to be left over on the bottom, and so they need to stay there. So nothing's left over here. It's a 1. So on top, 3 minus 2 for your A's leaves 1A. And you can just write that as A. You don't have to put the 1 there. Remember, these 2 canceled 2 of these, leaving 1. This 1 cancels 1 of these. So you're going to have B to the 5th, or you can think about it as 6 minus 1, and it's 5. So this can be rewritten if you want without the 1 in the denominator. You don't need it. All right, moving over now. This is 8 over 40. So if you think about that first, 8 over 40, you would simplify that. We can divide these by 8. And so you're going to get a 1 over 5. So when we set up this final answer fraction over here, we need a 1 up top. But when we have a coefficient of 1 in front of the variables, we don't have to write it. So I'm not going to throw that up there quite yet. But I do know on the bottom I'm going to have a coefficient of 5. It might be by itself. If all of these variables cancel, it might just be something over 5. But there's definitely a 5 that has to stay in the bottom. So don't divide 40 by 8, get 5, and throw it on the top. Just take a look. The 8 was smaller than the 40, which means you're still going to have something left over here on the bottom. Now let's look at the B's. There's 1 on the bottom, 10 on the top. This 1 is going to cancel one of those out. So I still have 9 on top. Other way to think about it is 10 minus 1 is 9. But now take a look at the C's. There's more on the bottom than there is on the top. So these 3 on top are going to cancel 3 of them on the bottom. And this is where we're not ready to go into negatives just quite yet. So we're going to say these 3 cancel 3 of these, leaving 2. But where are those 2 left? They're left on the bottom. They were not left on the top, because these 3 are gone, taking away 3 of these, leaving 2 left over. And this is our final answer. Now 3 minus 5 is negative 2. If you want to think about it like this, when you get a negative, when you subtract, just put it in the bottom, but don't write it as a negative. It's going to stay positive down here. You're going to learn that you can put it up top, but if you do, now it's going to be c to the negative 2. And I don't want to get too far into that because that's lesson 8.4. But for now, if you just did 3 minus 5, if that's the way your brain's working with this property and you get a negative, just know you're going to put it in the bottom. You're not going to write it as a negative. It goes on the bottom because it's negative. Otherwise, I think it's easier to just think about these canceling each other out. So 1b canceled 1 of these, leaving 9 on top. 3 C's canceled 3 of these, leaving 2 on the bottom. All right, if we understand all that, then we can do a really complicated problem like example number 3. So let's start with these big time coefficients here. Imagine them as a fraction by itself, and you had to simplify this. Can you divide by 2? No, this does not divide by 2. Only even numbers divide by 2. So can you divide by 3? Maybe. Well, let's try it out. 594 divided by 3 That works out evenly, but this is only going to work if the bottom also works out evenly. So 165 divided by 3. And I didn't press the 3. 165 divided by 3. That works. Okay, so I've simplified a little bit. Doesn't mean I'm done. So if I divide by 3, I'm going to get 198 over 55. Now, is this completely simplified? So I know 5 goes into 55. It doesn't go into 198. Maybe 3 if you want to try it. I know 3 doesn't go into 55, though, but you can try it. It doesn't go in evenly, so that's not going to work. 2 is not going to work. 5 doesn't work. 7 doesn't work. And so you might think that you're done. But when I do think of 55, it's one of those special numbers. If it repeats itself twice, 5, 5, 6, 6, 22, 33, those are all divisible by 11. Okay, so what we need to do is check and see, is 198 divisible by 11? And it is. Okay, so we're going to divide these by 11. And we're going to get 18 over 5. Now that it's small enough, we should know that 18 and 5 can't be simplified anymore. So when we write our final answer here for this big problem, we're going to have a coefficient of 18, and we're going to have a coefficient of 5 in our problem. All right, so those are taken care of. Now I'm going to move over to my A's. 7 A's, 9 A's. So these 7 are going to cancel 7 of these, leaving 2 on the bottom. I'm going to put it right there. Go to your B's. So I'm going to cross my A's out. 5 B's on top. This is 1 on the bottom. 5 minus 1 is 4. Or this 1 cancels one of these, leaving 4 on top. So B to the 4th sits right there. Cross those out. Looking at my C's, 11 minus 7, that's 4 again. Or these 7 cancel 7 of these, leaving 4 on top. My D's, now I have more on the bottom. So as soon as you look at this, if there's more on the bottom when you start, then your final answer is going on the bottom. This 1D cancels one of these, which means there's still 3 sitting on the bottom. D's are gone. E's, 8 minus 8 is 0. They completely cancel each other out. This 8 cancels 8 of these. And now 9 minus 2 is 7. These 2 cancel 2 of these, leaving 7 on top. And that's a completed problem.